prove that the sum of the squares of any two consecutive integers is an odd number. So it's quite a mouthful there, okay, but they do refer to two consecutive integers. So if I consider, okay, a particular integer, okay, any integer, right, n equals k, so then that means then consecutive integers will then equal to k and k plus 1. Okay, now they're saying prove that the sum of the squares of these, right? So I'm going to square them and I'm going to do the sum of the squares. So sum of the squares, so I'm going to square it, k squared, and I'm going to square that and I'm going to add them. Okay, so that's essentially what it's asking us to do there. So let's work that out, k squared, and then let's write out the bracket here twice. So let's expand this bracket then. So we've got first is k squared, outers is k times 1 is k, inners 1 times k is k, last is 1. So I get 2k squared plus 2k plus 1, okay. And what you can see here then is, once this is simplified, you can factorize out 2, but only for the first two terms. So you can do 2 bracket k squared plus k plus 1, okay. So I factorize out 2, but what you need to see here now is that that's of that form as well as we saw at the beginning, 2n plus 1. So that means it's got to be odd, okay, because it's of the form 2n plus 1, and remember 2n plus 1 represents odd numbers, yeah. That there essentially is a number, k squared plus k is a number, so when you times it by 2 it's going to be even, but when you add 1 to it it's going to make it odd. Okay, so we proved algebraically that the sum of the squares of consecutive integers is odd, always odd.